Hey there, Kimmer here. I just want to talk today for just a little bit about what happens when you're expecting integer data, but you get character data. And so let's go ahead and run this little program here. I just have something, considering it's hot out, let's ask for how many scoops of ice cream someone would like. So I go ahead and take in however many scoops. Scoops should be an integer. And then it should reply with however many scoops you're getting. So let's go ahead and run this. And notice it says, how many scoops of ice cream would you like? So if I put in the number 55, I know, a lot of scoops. But it should tell me you're getting a cone with 55 scoops. However, if I run the program again, and this time I put in, say, SDF, right? Obviously not an integer. It's going to tell me I get a cone with 0 scoops. So I have to try to be able to fix this particular problem. Now, some of you, when you run this, you actually might get a runtime error. Okay, either or. Just depends on your compiler, what version you're using. This one ends gracefully, if you will, but it does simply put a 0 here. So what happens is it is known as the cin failing. So I can do a simple while loop using a cin.fail function. So the fail bit is simply that. It's just something that if for some reason something doesn't work as expected with the cin, it's going to produce this little flag. And so the fail function is simply going to return that. And so if we do that, let's do this while, and we're going to then do a cout. That we'll just keep it simple for right now. Error. Try again. And then just a little message here, if you will. Then we're going to follow it with asking again. So don't forget, when you do data validation, you have to ask a question while they do something bad or something bad happens. Go ahead and tell them something's wrong, and then try again. Otherwise, you will loop forever. Okay, so let's see if this is going to work the way we want it to. So I'm going to save it. I'm going to then compile and run. Now, I'm always going to try to use the same data. So here's our 55 scoops, and that works out perfectly. But watch what happens when I run it this time. I think you'll be surprised. So I'm going to go ahead and put in my ASDF, and don't worry, I knew this was going to happen. I needed you to see that there was something else going on. So obviously it's in an infinite loop, so we're going to close this. So this particular fail, it's a function that when it does fail, if it does, there's a flag, and it checks to see what this flag is set at, meaning a fail flag. And the first time it fails, or actually any time it fails, it sets this flag to, yes, okay, it's true, it failed. So there's a couple things you have to do. First thing you have to do once it fails is you have to turn it off. You have to force it or clear the error. So we're going to do that first, and we're going to do the cin.clear. Now, this particular function does not clear the buffer. All it does is it sets it from a true fail state to clearing the fail bit, if you will. But the next thing we should do is actually tell it to take whatever is in the buffer and ignore everything. So we're going to use the cin.ignore, which you've seen before, most likely. However, it's going to look a little different. Okay, so cin.ignore. So what we're going to, normally we tell it some particular number and the enter key, whatever comes first, right? So this is typically how you may have seen it used. This number is, in some cases, an arbitrary number. However, it shouldn't be. So what we're going to do instead is we're going to say, you know what, let's find out whatever the numeric limits are for a particular stream size, their input stream. And whatever that maximum is, that's what we're going to use. So right in this case, instead of the 1,000, I'm going to put in this. So we'll talk about this, but it goes in place of the number. So it's calling on numeric limits, which now we have to include another file to be able to have this. So we've got the numeric limits. And it's also using something called stream size. So we have to include another one for that. So I know that's a couple things we have to include, but what that will allow us to do is to whatever the maximum value for your input buffer, and it's using something called stream size, which we'll talk about later. I know we could have used something else there for those people that have seen this before, but for right now it makes sense. So we're going to say whatever the numeric limits are for a stream size, whatever that max is. So notice that's a function. So it will then, this function returns a number, and then that number will be used. So on different platforms, different compilers, different things, it might be a different number just based on what it is. Okay, so let's see how this works. So if I save it, compile it, and run it, again using the exact same data. Let's try a 55, that worked out well. Let's run it again. This time we're going to use the ASDF, and there you go. There's our error message. And then it says, okay, error, try again. How many scoops of ice cream would you like? So what if I put in some more bad characters? Maybe some numbers in there. Still, try again. So what if I put in my 55? It works. Now, one of the things to note when you do it this way is when we run it, let's assume the user puts in 55 ASDF, all in one. What do you think is going to happen? It's going to take the 55. So it starts in the beginning of that buffer, and the very first thing it sees is the 5 and then the next 5. And so together, it knows that that is an integer, and it pulls that integer out of the buffer. So ASDF is technically still left in there, but at least it didn't throw an error. So this is how you can go ahead and begin to do data validation for inputs where you're expecting numeric data, but you're given character data instead. I hope this helps. We'll talk soon.